Yeah, the objective part of maths, the true and false part of maths is, of course, the least interesting and least important in some sense. The way our minds are wired is evil. Yeah, it's terrible. To be a mathematician, you have to be an optimist. They've memorized statements of theorems and they haven't got a fucking clue what any of them mean. It's just incredible. And there's a lot of people like that. It's really amazing.
So, welcome to Math Life Balance. Today our guest is Richard Thomas, professor in Imperial College London, working in algebraic geometry and mirror symmetry. Welcome, Richard. I'm excited to learn about your perspectives on math and life.
Hi, thanks for the invitation.
So, could you tell us what brought you into mathematics?
Oh, I guess I was always pretty good at it, and but I certainly didn't intend to go into mathematics until really my PhD. So it just never occurred to me that being a mathematician was a thing, or was. I mean, my parents always had the attitude that mathematicians were geeks and didn't do anything useful, or if they existed. I mean, I thought a mathematician was just a school teacher, I guess. So it never occurred to me that I would ever be a mathematician. I always wanted to be a scientist of some sort. And I was really into electrical engineering. I started out in my undergraduate degree concentrating very much on the physics side and the applied math side and fluid dynamics and stuff like that. And then I found, for instance, I loved multivariable calculus and Stokes's theorem. Stokes's theorem, divergence theorem. I just thought those things were great. Mainly, I mean, partly because they were just taught so badly as kind of statements that you had to learn and apply. And of course, I was determined to understand what they really meant or what was behind them or why they were true. And once you understand that, you get this buzz from having worked something out for yourself that was kind of, you feel like you're in part of some magic circle or something. Somehow it's extraordinary to me that it's still the case that so many of these things are secret, that they're just presented as facts to learn rather than to understand. And so I ended up working with Simon Donaldson as my advisor. And then he immediately identified that I didn't know any algebraic geometry, and so he made me do some of that. And now here I am, some kind of second-rate algebraic geometer.
Second-rate.
Coming from a very weird point of view, physics and complex manifolds, and I've never taken a course on the foundations of algebraic geometry, commutative algebra. In some sense, I don't know any algebraic geometry, but that's what I do.
Seems to work for you. So you made me curious in the very beginning of your answer with how do your parents change their attitude towards mathematicians, if they did, throughout your journey?
Oh yeah, they were very supportive of it. They're fine with it. I can't say they've ever shown any interest in it, like asked me to explain what I do or anything. But I think that's probably more my fault, that probably they did at some point early on, and I would have done such a dreadful job of explaining it that they learned not to make that mistake again. Yeah, do you find that? Do you find non-mathematicians show a fleeting interest in what it is you do?
But I think after all my stories, non-mathematicians show much more interest in mathematicians.
Yeah, I agree. I think that's true. They're interested in the sociology of it, maybe.
Yeah.
They're not interested in understanding. So, the thing that, to me, I think, if I live in a fancy part of London called Islington, where all the middle classes have fancy dinner parties and talk about art, and they all work at the BBC, and they want maths to be some kind of art. So they want it to be mysterious. They don't want to understand it. They love these cross-disciplinary activities where, some mathematician gets together with a playwright and they write a play, and it conveys nothing, right, other than mystery, and that's kind of what they like. That's a more artistic point of view on it. Whereas I'm always disappointed that that people have absolutely no no interest in understanding what we do. Of course, they could never understand necessarily the technicalities without lots of training, but to me, maths is all about ideas, and many of those ideas you can convey, and people would rather you didn't. I find really surprising, and I guess it's what sets us apart from other people, is that we really like ideas, abstract ideas, and that's why we talk about the beauty of maths all the time. And other people want the beauty of maths to be some mysterious artistic thing, and I don't think it is.
I had one happy moment though in my life of failures of popularizing math when I gave my mom the book of Edward Frankel, Love and Math. And I expected she would only read like the stories, not the math. But then she called me a few days later and she told me, can you imagine a triangle can have two sides which are rational numbers like 1 and 1, and the third side could be an irrational number like square root of 2.
Oh, fantastic.
And like she was shocked by that. And that moment was, I think, the happiest. The one moment when someone got actually interested.
Oh, how fantastic. That's great. I thought you were going to say she didn't just read the story, but she also looked at the pictures. Yeah, that's great. That's really good.
That was one time.
I guess this pandemic means people have a bit more interest in some aspect of maths, some statistics, but not much.
Okay, so since you mentioned that adults may have lacking interest in math itself, but you also mentioned when we spoke once that you teach math to kids in primary school. Can you tell about that?
Yeah, I wouldn't say I teach them. I mean, it's very important to me that I don't do any teaching at all. So me and another parent at this primary school, we just run a lesson once a week during the school day, where all the effort goes into preparing the questions. So we just set problems, and the kids tackle those problems, and we take 20 kids from across the school and we take them for 6 weeks, and then we change to a different 20 kids. So eventually we try and see the whole school. And it's just a typical London inner city state school. So it's the variety of kids is extraordinary. How this started was I volunteered in the school to be an assistant in maths class to the teacher, because I wanted to see what goes on, and I wanted to see if I could help in any way. And so quickly, the way the teacher used me was in getting me to take 8 kids out of the class who would be bored by the class, because she was focusing mainly on the other kids. So the 8 who were sort of brightest in some sense, or finding the material the easiest, I would take off and do something else with. But what I observed in these classes that I think maybe will be familiar to most people, and was familiar to me from my schooling, was that in every class there were always 2 kids roughly who were keenest, who always had their hands up first, who were in this race to answer every question first. And in some sense, they got something of the buzz of math. They understood the excitement of solving a problem, which is what I consider to be mathematics. And I felt that, firstly, they weren't really, they were rushing, so they weren't thinking deeply. They were stressed, so they weren't solving hard problems. So it was more about their knowledge. So I didn't like that. But much more concerning was that the rest of the class, when they finally solved the problem, they didn't feel the buzz at all, because, you know, those two had already solved it before them. So they felt stupid that they hadn't seen this before, that they hadn't solved it quicker. And so they all didn't like maths nearly as much. And I felt strongly that if you took those two out of the class, another two would emerge who would have their hands up and who would enjoy maths and, you know, get the buzz and so on. And actually, if you could slow them down as well, that would be ideal. And then if you took them away, the next two. And so eventually I came up with the obvious solution to this problem, was that everyone should be doing a different problem at all times. So me and another parent who's also a math professor or in economics set up this kind of maths club. But it's in the school, so it's not like after school that only the middle classes would come to. It's actually in school, and all 20 kids have a different problem, so all the effort goes into preparing the problems, and then it seems to us it works. So these kids, when they solve a problem, the difficulty, of course, is getting the problem the right level to the right kid. Very quickly we get to know the kids, we set them problems at the right level, and they get genuinely excited. It's much more pleasurable than teaching undergraduates when everyone's too cool. These kids, they think they're the only person in the universe who solved this problem, and they jump up and down and they punch the air, and it's lovely. So that's how I got into it, and yeah, it's been really interesting. I've learned a hell of a lot about how people develop mathematical thinking. I've changed a lot of my opinions. I've realized a lot of kind of problems in the way maths is taught. I'll tell you a depressing thing. It's kind of controversial, but by the age of 6, I can tell you that girls and boys do maths differently, unquestionably. I don't know whether this is genetic or it's, you know, to do with the way they've been brought up and parents being much more cautious with girls. But here's the standard problem, which in 99% or maybe even 100% of cases, boys and girls tackle in a different way. So you sent me some instructions on these interviews, and you said how I shouldn't discuss maths, technical maths. So we'll see if you allow this. I think you will. So here's the maths problem. So a snail is climbing a wall. It's a 10-meter wall, and it goes up 3 meters every day, and it slips back 2 meters every night. Okay, and the wall is 10 meters high. How long does it take the snail to reach the top of the wall for the first time? 24-hour cycle, you go up 1 meter. So to go up 10 meters, you might think it takes 10 days. So you think the boys or the girls answer that way?
Look, I spent the last many years on trying to destroy in my head all the gender stereotypes and trying to convince myself that people are not defined by them. So
I know it's depressing, but unfortunately, it's an observable fact that I think 100% of the boys, probably it's less, answer 10, and 100% of the girls, they don't do that. What they do is they draw a pie chart, a bar graph, and they draw every daylight, every nighttime, every day, every nighttime, and they draw this bar graph, and they record every single number on it all the way up to 10, and they always get the correct answer. So the boys are always wrong, the girls are always right, and the girls get whatever the correct answer is, I guess 8. And then the follow-up to this question, aimed of course at the girls, is to say, if it was 100 meters high, how long would it take the snail? And I would say more than 50% of the girls continue for the rest of the hour drawing their bar charts, making them bigger and bigger and bigger. And of course we asked them to, okay, let's stop, let's try and work out a way of working this out without going through every day and so on. And their resistance to doing so is enormous. And of course, by now the boys have a huge advantage, because by now we've told them that 10 is the wrong answer. They've worked out why that is. They've got the answer 8, and then they immediately get 98 for the next one. And some of the girls, we spend a lot of time with them, and they more or less refuse to get 98 because they don't want to. They want to go through their safe method that they know works. And I find that extremely interesting, but also depressing. And the reason I find that depressing is because the girls' method is absolutely ideal for answering school questions. And so the teachers love it. And the teachers, this isn't something, this isn't something the teachers are going to do anything about. So of course we're then excited to design other questions which probe similar things and which encourage the girls to try to spot patterns, take leaps, make shortcuts, be a bit more adventurous and dangerous, and then check their answers afterwards and so on. And we can do all that, but the teachers are never going to do that because the girls' methods will always get them 100% in exams. And it would just, the school exam system and the syllabus and so on is perfectly designed to be annihilated by their methods. And they've got the perfect method. And so, of course, they're never going to be encouraged to take shortcuts. And that's what I find depressing, is I can't see it ever changing. So I can't see many of these girls becoming mathematicians, which I think is a great shame.
I don't know what to answer, Richard. First of all, while you were telling this story, I thought the answer is 9. Second...
Oh, now I have to think about it. Yeah, I think it's 8.
Secondly, you remind me of all those tens of thousands of times that I've heard in my late years of high school that girls cannot, and university, that girls cannot do math research, and how, unfortunately, that has a lasting effects.
Of course.
But okay, so what?
And of course, girls can do and do brilliant maths research, and I'm just worried that the system is dissuading so many of them for this reason.
I actually had the opposite problem. So,
one of your parents is a mathematician, is that correct? Or a family relative? Or no? Okay.
No, so the opposite problem was that many people would tell me often, including some of the people people I trusted, all those adults, they would tell me that, oh, you get good notes in your tests because, girls are so careful and, do all these diagrams and stuff. And boys are the talented ones. That's why they do worse at tests. And this constant paradigm of accuracy versus talent, this was with me always. And I mean, I even was told a few times, and it hurt, that I have good notes at school because I'm not interested in anything seriously.
Wow.
And that was also named as a reason why I cannot be a researcher.
Right.
There were so many.
Good Lord. Oh, I'm very depressed to hear that. I'm sure I was guilty as a child of criticizing other children for, let's say, having very neat notes, or as an undergraduate, because I had my own insecurities about the fact, that I tried to work in the quickest, most efficient way possible so that I could get down the pub afterwards. And there were all these students who made me feel desperately insecure and concerned that I was missing out because they were in the library until 2 a.m. doing that thing where, they use the yellow marker pen to highlight all the important things without necessarily absorbing any or looking at any of the important things. And it was very important to me that they were wasting their time. I had to believe that, otherwise I was in trouble. So I was very critical of such people. But now I feel guilty about it because of what you said.
Oh, I don't complain about kids of my age. I do feel upset with all the adults, and I mean so many adults teachers, I mean people in charge who told so many things that are demotivating. And on the other hand, we were always told that guys cannot learn languages. I mean,
bizarre. But why would they say that? That's so extraordinary. I don't even see why it would come up. Like, it just seems very strange to praise someone and then to find a reason to row back on that, and a caveat. That seems really strange. Yeah.
I think maybe I should stop talking. That's your intro. But I believe that the whole, like the fundamental problem in Russia is that there is a lot of talent and there are little resources given, little like economical resources and stuff. So the competition is high, but it's not open. There is no proper open competition. There is inner pressure within the society, which leads to.
I see. So from a very young age, your future prospects are being discussed because they have to decide whether to devote resources to you or send you to a specialist school. Or yeah, that doesn't arise in that doesn't really arise in Britain, unless I guess there's some issue with parents sometimes deciding to send kids to private schools, but other than that, it doesn't arise. Right.
Well, that's interesting, but let me ask you about something else. So if kids ask you about your work, what do you do? What would you tell them?
Oh, they never do. I mean, if you were thinking of the primary school kids, they have absolutely no interest in me. That's for sure. Yeah, they're only interested in themselves. That's fine.
So what gives you the drive to do mathematics?
Oh, lots of things, of course. There's many things that I enjoy about it. Many things that I enjoy less about it. I know. I think there's a moment I can pinpoint that I became a mathematical researcher. Although this, of course, is with hindsight, and is probably too convenient. But I think age 14 was that there was, until that point, I think in school, everything had been clear. So and I think the teachers were still trying to make things clear. So things weren't just presented as facts you had to learn or mysterious algorithms, or mathematics was about things which were evidently true or that you could see why they were true. And I'd never had any problems with teachers asking why is that true and getting an answer. And then the first time this kind of failed, it seemed to me, was Pythagoras' theorem. I was told Pythagoras' theorem was a fact and I had to use it. And I wasn't really allowed to know why it was true. And when I pushed and asked a bit more, I was shown a page of Euclid's book or something where he draws squares on the sides of the triangle and then divides them up into a million pieces, and it looked completely intimidating because it was in Greek and it was old, and I was terrified, and I was quite sure no one could ever understand Pythagoras' theorem. And I was worried about that. Suddenly maths was a different subject than I thought it was. And maybe 2 years later, I was 14 probably, I was in the south of France on a family holiday, stuck in a caravan on my own. It was pouring with rain outside. I couldn't go outside. I had to sit there. I had nothing to do. I didn't have a book with me because I was meant to be in another tent. And all I had was, amazingly, pen and paper. And for some reason, I decided to play around with right-angled triangles with this Pythagoras' theorem. And I just drew a triangle, and I did the only thing that occurred to me. The only thing I could think of to do was to drop a perpendicular to the hypotenuse. And then immediately I saw there were similar triangles, and I wrote down the relation that gave on the ratios of the edge lengths. And that was it. That was Pythagoras' theorem. I couldn't believe it. I was so excited. And I think that's when I became a mathematician. But I've forgotten what your question was, and I'm sure I surely didn't answer it.
That's a good story. So what does it mean for you to be a mathematician?
Well, I think what happened in that story has been a big part of my approach to maths, and I'm sure it's the same for most other mathematicians, which is just that maths for me was always the thrill of working out what's really going on. And it happened, of course, more and more as you go into more and more advanced maths, and often maths that your teacher is less and less familiar and comfortable with. More and more becomes mysterious. And because of my early success in understanding Pythagoras' theorem, I just continued, reverse engineering what was really going on from all this nonsense we were taught in lessons. And even at university, I mean, I went to Oxford University, fancy place. Some of the best mathematicians in the world teach there, but it still happened. They would teach statements of fact, maybe with proofs as well, but with no insight, they weren't telling you how to think about it. Of course, often they did, but there were many, many examples of fundamental concepts and theorems and results where they were just presented and you were supposed to apply them, or you were supposed to learn a proof, but there was no discussion of the insight or how you're supposed to think about it, or what the idea was, what was going on. And that always upset me, but I always eventually enjoyed reverse engineering what was really going on from what we were told. And I'm sure that's what made me a mathematician. And all the time, every time something more complicated came along, because maths is so psychological, like everyone else, I would just think, well, this time I'm buggered. There's no chance of me ever understanding this or reverse engineering this or working out what's going on. But eventually I always got there. And then amazingly, I just continue that into research, and it turns out that works.
So
But you never really taught that, right? I don't think. Maybe things are better now.
What do you mean?
Well, people seem more enlightened about what works, and no one writes Bourbaki books anymore. People make a genuine effort to try and explain how to think about things.
But then people write papers, and in the papers, in 90 papers out of 91, there is no attempt to explain why some theorems.
I disagree with that. I mean, of course, people don't do a brilliant job because it's impossible to do a brilliant job, because you can't upload what's in your brain into someone else's brain, especially because their brain works differently from you, and what they're after, what would work for them, is different than what works for you. And so, in your 91 papers, maybe 50 of them made some kind of attempt. It's just, I can't do the maths now, but 40 of them kind of failed for you, but maybe they worked for someone else. So, I watched, as I did my homework and prepared for this by watching some of your videos, and oh goodness, this is embarrassing. I've forgotten his name now, but a topologist that you interviewed, a German guy.
Thomas.
Yeah, I should be able to remember that name, shouldn't I?
Yeah.
He was very critical of maths as an enterprise for not being able to give good feedback honestly to speakers and people writing papers. And I completely understood his point. I agreed with his point. We're much too polite in some sense, and we don't want to open that kind of worms, and maybe we should. But firstly, we have more social skills than people give us credit for, and we realize, that however constructive your criticism is, it hurts people and often doesn't help them. So that was one point. But the second point that I thought he didn't seem to acknowledge at all is just that we all think different ways. So what's the correct way to write or give a talk or whatever is completely different for one person to another. So it's not clear to me there's an easy answer to that. I guess that's part of the enjoyment of maths, is talking to more and more mathematicians and eventually finding collaborators with whom you think not necessarily the same way, because then maybe they're not so useful as a collaborator. Maybe they think in a different way, but establishing a way of communicating, like finding a way of explaining something. I know with certain of my collaborators exactly how to explain something so that they will understand.
So it's actually funny. Mathematics is believed to be the part of science which is completely objective, and there is only one right way to make things. And yet you say that mathematicians see mathematics in such different ways that it's hard to say anything objective about.
Yeah, I think that's true. I think, yeah, the objective part of maths, the true and false part of maths is, of course, the least interesting and least important in some sense. Yeah.
So how do you work on a math problem?
That presupposes I work on a math problem, right? But you know what I mean? I don't necessarily.
Or how do you do research?
Yeah, because I don't necessarily, pick a problem and start working on it. So the answer to that question has varied over time. I'm at a stage of life where I never think about that. I have too many things going on and lots of things I'm interested in, and I have more knowledge and experience than I had 20 years ago. So I can take more from more seminars and more people. So because of that, just in my daily life, I am exposed to a great deal of mathematical activity and ideas, and more than I can possibly, more of those things interest me than I can possibly work on. So that wasn't the case, of course, when I was younger, but it means that a lot of my time is spent, deciding to discard various ideas or just note them down for later or give them to a student or something, and force myself to think about what it is that I'm meant to be finishing off. But so I tend to pick problems or things to work on based on winnowing out. There's lots of things I feel I could work on, and then I try and choose the one that I think is most ambitious or interesting, but within the bounds of feasibility. And then how do I work on it? I think I do what all mathematicians, actually that might not be the case. I do what I always suppose all mathematicians do, which is I construct simpler and simpler and simpler toy models of tiny parts of this problem. I try to identify, where I think the stumbling block will be, what the most important point is, what the most important example will be, and then I try and construct smaller and more ridiculous toy models of that until I get to the point where I can solve something or calculate something. And then I start coming backwards and trying to generalize it until I can do the actual thing I wanted to do.
So do you feel happy when you compute like a tiny example?
Yes. Yeah, that's very important. Yeah. Yeah. Your postdoc supervisor, Rahul, often says, to be a mathematician, you have to be an optimist. And I kind of agree with that. Of course, there are counterexamples, but I think more important than being an optimist, I think something that he does incredibly well and that I've learned to do is that you have to take pleasure from small. I daren't even say progress, because you couldn't call it progress. You have to take pleasure from calculating examples, from understanding one more thing than you understood yesterday, one tiny thing, even to the point of, the thing that you thought you understood yesterday, which you now realized is false. You have to take pleasure from that, because that's progress. And I don't know why, but I think I am quite optimistic, but also more than that, I think it comes naturally to me to enjoy having that's why I do maths, for that, just having that tiny insight into a little problem, solving some tiny little calculation, whatever. Somehow I naturally see the importance of that. And I think that's the only reason I can continue with maths. Otherwise it'd just be too hard, too stressful, especially when I was younger. I mean, it's easier now, but that's always what I think that would be my superpower. If I had one reason why I felt that in my office of 5 people doing a PhD when I was a PhD student. If I wondered why some of those decided to give up maths and I carried on, I think it would be that I didn't look for big results. Of course, in the back of my mind, maybe I was looking for them, but day to day, I took pleasure from unraveling a tiny little mystery. And I didn't choose to do that. I happened to be that way.
But okay, that's great that you are this way, lucky you, but what do you think are the biggest obstructions for other people to enjoy doing math research?
Yeah, just putting pressure on themselves, I guess, is one thing.
How can one not do it? I mean, if it does not come naturally.
I mean, we all do it, yeah. Yeah, I mean, it's to do with your value system as well, isn't it? It's what's important. It is true, too many mathematicians that have their eye on some prize and they don't value enough small understanding. I find it difficult sometimes with PhD students. We do something on the board and we've understood something for some, for the one-dimensional node or some terribly simple singularity, or we've done some calculation, and I'm really pleased with myself, and or I'm really pleased with for us, or I'm really pleased with the student, and the student's just explaining to me why that can't possibly be of any use to this problem that we're eventually aiming for. Or of course, I think most people recognize, or certainly most people who've advised students recognize this feature that graduate students in their first year or two are experts at telling you why things can't be done. They have elaborate, fantastic, watertight theoretical proofs as to why a particular problem is not worth studying. And you understand that the brain's trying to conserve energy, it's lazy, it finds these incredible ways to prove that it's not worth embarking on this hard calculation. And then they learn to change. But for some students, that never leaves them in some sense. They can't see the value in small things, and they'll just constantly tell you, well, so what? That's still not the big thing, and it's got us no nearer. I'm like, no, who cares? Look, come on, isn't this cool? We've understood the ordinary double point. Yeah, I think that's really important. I didn't realize it when I was young, but I realize it now. I always did it, but I didn't realize how important it was.
So what are the main things you want to teach your students about doing math? Besides this
So
small
many things, but yeah, all those things we've discussed. Yeah, talking to people, getting the key example of a theory. I'm always trying to tell them, don't read that 1,000-page book. Buried in that is the one key example, or maybe it's not even in the book, because as you said, we don't write so well. There's one key example or two which illustrates every phenomenon of that theory, every problem, if you understand that example, you could, given enough time, reconstruct the theory. So don't read the 1,000-page book, talk to people, because people know that example. Yeah, I mean, that's the main thing. And then, of course, that's the hardest thing. And we have a huge problem in maths that people grow up in this rather dog-eat-dog, competitive, individualistic sort of system at school and university, where people don't work very collaboratively and they feel they're competing with other people and they're trying to show off, not necessarily in a bad way, just because they're maybe insecure and they think everyone's better than them. And so I think people are probably better at this now, and I think they're probably better at this in the US than they are in Europe, and they're probably better in Europe than they are in Britain. But we're all, as is well known, we're all very uptight and awkward people in Britain. But people don't discuss enough with each other. and they make maths far harder than it has to be, and they think that what worked for them as an undergraduate must be what they have to do as a graduate student, or even if they don't think that, it's so ingrained in their subconscious that they do it anyway. So yeah, I just desperately try and encourage people to talk to others, and I feel it's probably a losing battle. Like, I think they probably ignore me, and I think they maybe listen and they maybe agree at some level, but not enough to actually do anything about it, because they know it's painful. They know they're going to make a fool of themselves. They know that they'll feel that they should know what the other person's talking about, or that they should know that piece of theory that the other person is taking as read. And they don't want to go through that pain. So they find it easier to just go off, hide in their room and read their book, or do the maths the way they've always done it. And that's so inefficient. Yeah, it's like trying to persuade students to why they should go to seminars. It's extremely hard to do, because you can't pinpoint. I mean, I've had students come back and say, but it's not relevant to my PhD topic. And that's just such a wrong thing to say. It's so hard to put into words why that's so wrong and why it's so important that they go to seminars and discuss with people who are maybe in neighboring fields but not working on their exact PhD topic. It's so important, but it's so hard to convince people. Did you need convincing?
I mean, I have the opposite problem as your students. I'm happy to superficially get an impression of different parts of mathematics, and that gives me the joy, but not the digging into the actual detail. So going alone and reading a book is like the torture that you can offer me.
Yeah, I'm not sure how much I believe entirely what you're saying, but since I'm not meant to be interviewing you, we won't push that point. But yeah, isn't it amazing how many mathematicians are comfortable reading a 1,000-page book? There's something wrong with that. That's incredible. I mean, it's great if you can do it. It's a great talent. If you can absorb that amount of complexity, that you can imagine that would be a great talent to have, if you could also do the big picture stuff and sort of see the big ideas and conceptualize. Maths is about packing things down into small conceptual boxes that we can all that we can upload into our brains. It's not about 1,000-page books. So yeah, I find a great deal of, let's say, students have this amazing ability to cope with complexity that I can't cope with, especially probably now that I'm older. Probably my ability to deal with detail is probably reduced. I've no real idea. But I do find, my students are way better at than me when we're discussing complicated technical arguments. But unfortunately, because that worked for them at undergraduate level, too many of them sort of hide behind that and continue to do it, and don't do what's hard for them, which is trying to find the easy way to do it. Try and find the concepts which makes all of that obvious, makes it clear what you should have done. Try to find the pattern, which says that it takes 98 days to reach the top of the world rather than drawing the damn graph.
I wonder, did you have to adapt yourself somehow? Did you have to change something in yourself or in your attitude on your, I don't know, during your PhD or afterwards?
I think that laziness is very good sometimes. So what did I have to change, or what? I mean, one thing I have to work on is the opposite of that laziness. I mean, driving yourself to push through hard stuff, or stuff that you're uncomfortable with. God, that's hard. I'm sure that's what trips up 50% of people who set out into maths and kind of don't make it, as it were, or give up. I'm sure it's just the brain is very lazy and very good at conserving energy and just forcing yourself to deal with something you're uncomfortable with. Yeah, that's another thing lots of students like to say is, oh, that's too algebraic for me, or that's too geometric for me, or my particular talent is, I'm looking for something in this direction, and they narrow themselves down more and more and more. And of course, they have to force themselves over that hill, force themselves through the thing that makes them uncomfortable. And then, of course, you suddenly become comfortable with it. So I've had to learn how to do that, as we all do.
Do you have any tricks?
Any tricks? No, now I'm wary of answering your questions because I imagine many young people watch these videos more than older people. And all of my answers are colored by my current experience, which is an old person. And I'm sure I felt differently when I was younger. But now it's much easier because I've done it so many times in the past. I've forced myself to confront something that makes me very uncomfortable, whatever it is, homological algebra or whatever it is. And I've come out the other side and I know that it works. So now I have less trouble forcing myself to do it. So no, I can't tell you my tricks. It just, force yourself through a few times and then you'll realize it works. But don't be happy. Yeah, don't settle for a partial understanding. I guess that would be my tip, right? Keep going. Even when you think you understand it, force yourself to do yet more, to tie it in with some other understanding or some other way of looking at it. Or, if there's 6 ways of proving a theorem, it's more important to understand the links between the 6 proofs than it is to understand any one proof. And that can be boring because if you're the type of mathematician who has your eye on the prize, then of course you're like, wow, right, great, I understood this now. I can get on with doing what I'm really meant to be doing. And I don't think you should do that. I think you should spend more time understanding it better, understanding other approaches to it, understanding the links between them. I think that's really the most important thing. Letting it really sink in, sleeping on it, really conceptualizing it and understanding it properly. And so it becomes natural. Again, I have this habit of prattling on, and I've completely forgotten the question. I have no idea what we're talking about, what I was supposed to be answering. I apologize.
No, that's an interesting advice about partial understanding. But every time you say that people have their eye on the prize, my impression with the math community is that people are more afraid not to not get the prize, but just that everyone else is doing so much better and understanding so much more. And while you spend your evening understanding this tiny example, someone else is finishing their paper.
Yeah. Yeah, that's inevitable, isn't it? That's human. The way our minds are wired is evil. Yeah, it's terrible. Yeah, I mean, all I can say is what everyone else says, which is that we're all insecure, we have imposter syndrome. We all, I go to a conference even now, and there are so many brilliant people discussing insanely complicated structures and concepts at huge speed. I can't possibly understand it, and I can't possibly understand how they can do it so easily and so manipulate things so fast. And all I can say is by the time you get to my age, you just realize that it's not worth worrying about because I don't know. There's some kind of bias in who you see doing that. You only notice the people who intimidate you. You don't notice everyone else. And some of those people who intimidate you, you're right to be intimidated by. They're really amazing. Well, that doesn't make it right to be intimidated by them, but you know what I mean. But 90% of them aren't. Somehow maybe they're amazing at something, but they're not tearing up research so fast that there's no place for you to do your research. It isn't that way. I don't know why it isn't that way, but there do appear to be so many incredibly smart informed people in maths who are so much better than all of us. That's what it appears when you talk to people, but it's obviously not true. So I've never managed to explain it. I don't really understand it. An uncharitable point of view, which might be true in 50% of cases, is that essentially people are bullshitting. It's certainly not true in all cases, but I've certainly over the years realized that certain people who appear to be very fast and on top of everything really are not. They're very good at using the words. They've learned what order to put the words in. They've memorized statements of theorems, and they haven't got a fucking clue what any of them mean. It's just incredible. And there's a lot of people like that. It's really amazing. So yeah, you just have to ignore it. It does. It's a shame, isn't it? Because conferences can be great, but it's hard not to be depressed by all these people who are clearly doing so much better than you are. But yeah, you just have to remember they're not at all. We're all just trying to understand a few small things better, and if you can take pleasure from that, everything else follows. Everything else takes care of itself. Easy for me to say. I don't know, but that's true.
Oh man. So I was wondering, you mentioned that you give kids different problems so that they're not distracted by competitivity. And yet when I talked with you, you're told that what drives you to sometimes drives you in like making next steps in research is some kind of competitivity, maybe with your, or so is competitivity like, how competitivity in your opinion affects doing math?
So I am naturally, as a human being, aside from mathematics, reasonably competitive, and I don't like that about myself, but I have to admit it's true. And at times that's certainly driven me to do maths or push me to work harder at maths or something, but I've no idea if it's been good for my maths. I am not at all convinced it has. Like, there've been times when I'm rushing through something with my eyes on the prize rather than, and I end up spending far too long. It takes much longer to prove a theorem or to get to where I want to get to, because I didn't take my time and I didn't meditate on the thing that I thought I understood that was much simpler. And it was only when I spent the time to really absorb that and see it from a different point of view and make the links between those points of view that I was able to really get on and solve the final thing that I was aiming for. So I'm not sure competitivity has helped me, but maybe it has. I don't know. But yeah, it's just another part of the evil human mental wiring, isn't it? Yeah, there's so many. Maths is so psychological. Do you think there's well, maybe not physics. Do you think there's a biology or medicine YouTube channel where people are interviewed about the psychology of doing biology? I can't imagine that in other subjects they're as obsessed with the psychology of their subject, about how you manage to con your brain into doing this thing that it clearly shouldn't be doing. I think this, I've no idea. I've never actually looked into this. It's only just occurred to me now, but I think this is a purely mathematician's obsession.
I don't know about all mathematicians. I'm personally obsessed with it, but you just mentioned in the beginning that you're annoyed that other people, when they ask you about math, only care about the psychological aspects. So, maybe some.
No, I think more sociological aspects. Yeah, everyone likes a story about Galois and his duel or whatever it is. I think, and they want to hear stories about mathematicians who have their breakfast on their shirts and only look at their feet and so on. I think they're not so interested in the psychology of it, but mathematicians, I think we're all obsessed.
Really?
Psychology of maths.
Really?
Unless maybe one or two people to whom it comes rather easily. Maybe they're not interested in the psychology of maths. I think for those of us that it's a battle, I think we're all obsessed with it. I mean, that's kind of what it is day to day, right? It's a battle to convince your brain to do something that, in some sense, it doesn't want to do.
I have an impolite question for you. You can skip it and not say anything if you don't want to comment on it. But I'm curious, when I look at job advertisements and kind of announcements of fellowships and stuff, in the last years, they all have, extra descriptions on the colors and genders of the preferable candidates. So I wonder, how does it feel to be a successful white man in 2020s? Is it like the world, including academia, feels like it's a tiny little against you, or that's not how you see it? Or
I think very occasionally, I don't think it's important that occasionally you feel that way, because I feel that way, because I'm prone to take things a bit too seriously and think everything's about me. I'm a human being, but given the bigger problems that people are trying to address, I think it doesn't matter if very occasionally I feel like slightly under attack, or occasionally you get emails from people saying, why hasn't your department, or why don't you commit to employing as many people from a certain underrepresented group in the percentage that they come through your undergraduate program or something. The fact that you're not doing that is proof that you personally are racist, sexist, and everything else. And why aren't you doing something about it? And though it's hard not to be hurt a bit by things like that. And you shouldn't be. You should just ignore them, but or think about the issues. But it's tempting to reply, which is always a mistake. Anyway, I don't think this was your question. That's kind of a digression. I think it's difficult. I think it's a great shame that maths is not changing faster. I mean, I find mathematicians generally very thoughtful, caring, conscientious people who want to do the best. Of course, there are exceptions. But somehow, despite everyone's doing their best and lots of initiatives and attempts to improve things, things are improving only very slowly, and that's a great shame. But it is a bit of a shame that we beat ourselves up about it so much, as if it was our fault, when I know it's an easy cop-out, but I think a lot of these things, the problems happen much earlier than the hiring committee. And as I said, we've discussed the differences in 6-year-olds' approaches to maths problems. And I'm sure those things can be fixed, but it seems they're not going to be fixed by us worrying about our hiring committee. I guess that will make some very slow progress, as we've been seeing, but it will be very slow. As we hire, let's focus on women. If we hire more women, that will provide more role models, and it will lead to more women coming through and so on. But it's an extremely slow process, is what's transpiring. Whereas if we could get into households when children are 2 and 3 and talk to the parents, I think you could have much bigger impact. But nobody's doing that, and that I know of, and no one's interested in doing that. But I think I think people understand. So one thing that you never see at the bottom of those emails, which you would like to see, right, is that there's a focus on hiring people with a background which is poorer than other people's background. So people who come from poorer or working class backgrounds are appallingly represented in academia. And no one's addressing that. And I understand why. It's because it's very hard to get figures on that. And it's very hard you don't want to be going around classifying people as to how well off they are or were. or, you know, how interested your parents were in education or something like that. But it seems to me those are things we should worry about. And that's when you can change things, right? You see that when a family really care about education, their children do better. When a family really care about their daughters doing science, then things go better, you know. Hence, we have this thing that a great deal of the women in maths, one of their parents is a mathematician. I mean, in one sense, that's slightly depressing, and in another sense, that shows. I mean, it's optimistic. It shows that we can change things if we have a different attitude towards children's education, how children learn, and if we challenge how they go about things and the comfortable ruts they maybe get stuck in, and all these things can be changed, I think. But there's an awful lot of discussion about what we're doing wrong way later, at the age of 20 and 30. And I think that's just nibbling at the edges, and things need to change at the age of 2 and 3, and that's hard to do. And I don't see people really discussing doing that. And there's no real interest. I mean, you know, at the school I work at, there's no real interest in them changing anything.
So, Richard, I forgot to ask you, do you have any funny mathematical episode to tell us?
Well, actually, that was the one thing I prepared. I did think about that because I noticed you asked everyone else. And I sympathized with them that it's very hard to come up with something on the spot. But I remembered one fantastic thing happened. I was in Turkey in one of the Gokova conferences in geometry, and Mikolkin was giving a lecture, and there was a huge earthquake. And we're all looking around at each other thinking, what do we do? What do we do? And we're looking for a leader to kind of leave or tell us what to do. And the reason we didn't all just run out of the building is because Mikolkin was completely unaware, of course, of this earthquake, because when you're giving a lecture, you think you're relaxed, but you're as tense as hell. And you're so focused on your audience and your lecture that you would have no idea if the world had ended. And so Mikolkin carried on giving this lecture, and we were all so damn polite. No one interrupted him, no one stopped him, and we all sat there, no one left the room. Or that's my memory of it anyway. This was 25 years ago, probably. And then the earthquake stopped, and he finished his lecture. And then when he asked for questions at the end, we told him that he'd just lectured through an earthquake. I thought that was a typical mathematician story.
Was he surprised?
Yeah, he was, yeah.